Hi everyone. Today I'm going to be doing the chemical traffic light experiment, which is an example of oxidation and reduction. So the main chemical in this is indigo carmine, which is basically a food dye that has been approved in the US for certain cakes and additives. And in Europe, it's also been approved for different, really any pastry for dyes. Today, I'm going to be using it for something different though, and that's for this chemical traffic light experiment. It's basically like when you have a oxidizer, so that's, in this case, our oxidizer is going to be our sodium hydroxide, which is also lye crystals, which you can just find at the hardware store that's sold for drain cleaner. Then the reducer is going to be just sugar, glucose or dextrose, which is going to be our main reducer that's going to be triggering this reaction. Okay, let's get started. So for starters, I'll take these three chemicals: sodium hydroxide, dextrose, and indigo carmine. These three are going to be the main chemicals in this reaction. The sodium hydroxide and dextrose are easier to get, but the indigo carmine can be a little bit harder. So to start things off, I'll add about 150 milliliters of distilled water into a large beaker and turn on the stirring. The stirring is supposed to be a little bit low because I don't really want a corrosive solution of sodium hydroxide splashing everywhere. I'll start by adding 3 grams of dextrose into the solution and let it stir. It's pretty obvious I turned it up a little bit too high, so I had to turn it down, because a splashing solution of sodium hydroxide would not be fun. Just as a quick safety measure, sodium hydroxide in water can be very hot, so it's important that I don't have the heating on at all, because it could start to boil, which is not good to have sodium hydroxide vapors in the air. Anyways, we'll let this stir for a while, and we'll move on to using the indigo carmine in our next solution. So to start it off, I'll get a small flask, and then I'll drop in a stir bar. I'll start by adding 100 milliliters of distilled water, but it's pretty obvious I was not being very careful and I spilled a bunch. This wasn't really a big deal, and I just add a little bit more. I'll get out the indigo carmine now, and I'll have to add a very small amount, about 20 milligrams, which is not very easy to measure out, but I just have to eyeball it, but it's hopefully going to turn out okay. Normally you have to add a very small amount, but since this was store-bought and sometimes it's not very pure, you have to add a little bit more. Anyways, once I got enough in, I just let it stir for a while. So you can see it got a little bit darker, and that's just because I added a little bit later because it just didn't seem dark enough. Alright, I poured solution A into a bottle and I added a funnel. Normally it would be better to hold the bottle and the funnel, but I only have 2 hands, so womp womp. Anyways, when I added the indigo carmine, it turned green almost the second it touched, and this is because the indigo carmine is sensitive to the pH change. Since the pH of the sodium hydroxide is very basic, the indigo carmine color will also change. Anyways, I'll explain what's going on now. When the indigo carmine touches the sodium hydroxide, the basic solution turns it from blue to green. But the reason why it's going to red and then it will be going to yellow is because it's also sensitive to oxidation and reduction. Indigo carmine is very sensitive to pH and also oxidation. So now the dextrose is reducing it to yellow, and now that it's yellow, it can be shaken and the oxygen in the bottle will react with the indigo carmine and start to change it back to green. After a few runs, the dextrose does start to run out, so you end up with a little bit of a less reaction, so there's barely any red and it just goes almost from yellow straight to green. Or it will stop going to yellow and just stay at green. So I guess that's it. This experiment was very successful and I still have this. So, green. So since it's taking it's a little bit too easy, that probably means I didn't add enough, that probably means I didn't add enough dextrose, but that's not a big deal because it still works. And in total, I just feel like it was successful. So, that to the side. Thank you all for watching, and a shout out to Nile Red for giving me the idea for this. I'll leave a link to his video in the description, and if you want to check out his channel, there'll also be a link. So, bye.